In the previous two videos, we defined the definition of a derivative, and we looked at the derivatives of some standard simple functions. So in this video, we're going to continue on that progress and define some more advanced rules which will allow us to take the derivative of any function that we come across. Okay, so if we know the derivative of a given function, there are some rules that we can use to look at some various special cases here. So let's imagine we multiply our function times some real number a. So what's the derivative of a times f of x? Well, luckily for us, the derivative is what's called a linear operator, because we have that derivative is going to equal a times the derivative of f of x. So if we know the derivative of f of x, we multiply that number times a. Simple enough. All right, what's the derivative of f of x plus g of x, some function f and some function g? So the derivative of a sum of two functions is equal to the derivative of the first plus the derivative of the second. So if we know the derivative of each of the functions individually, the derivative of their sum is the sum of their derivatives. Nice and convenient. All right, the product rule is where we start having to remember things. So the derivative of f of x times g of x, the derivative of a product, what is this going to be? So this is going to have two terms. The first is f of x times the derivative of g of x plus g of x times the derivative of f of x. So this one as well isn't that bad, because the derivative of a product is the first times the derivative of the second plus the second times the derivative of the first. So again, that's not too bad in the end to remember. All right, quotient rule. We have two functions divided by one another. In fact, this is a special case of the product rule and the chain rule, actually. So if we don't even actually need the quotient rule to derive it, but I'll mention it just because it's a commonly used and useful thing to know as well. So if we have f of x divided by g of x, the derivative of that is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. So unlike the product rule, we have the product rule on the top, except there's a minus sign instead of a plus sign. So we have to remember that this term is the second term and not the first term. And our denominator gets squared. So we have the denominator times derivative of the numerator minus numerator times derivative of denominator divided by denominator squared. So the key here is remembering that we have the squared on the bottom, and then we have the minus sign in the term that has the derivative of the denominator. All right, and our final rule, the chain rule, that is if we have a function inside a function. So we have g of x, and we take the function of g of x. So f of g of x, as we say, derivative of that is going to be equal to the derivative of f of g of x times the derivative of g of x. So we take the derivative of the outside and then the derivative, multiply that times the derivative of the inside. So we'll see what we're talking about here with some examples and make things more clear. So we'll say d dx of 5x squared. So we know from polynomial rules that the derivative of x squared is 2x. So 5 times x squared is going to be 5 times 2x from the scalar multiple rule, giving us 10x. All right, that's easy enough to work with. Similarly, d dx of 10 sine x. We know the derivative of sine x is cosine of x, so 10 times that is 10 cosine x. All right, for a sum, d dx of x squared plus x to the fourth. The derivative of x squared is going to be 2x. Derivative of x to the fourth is 4x cubed, so the sum is the sum of the derivatives. Easy enough there. All right, derivative of e to the x minus 1. We know that the derivative of e to the x is e to the x, and the derivative of minus 1 is 0, so that is just e to the x. Now getting into the more interesting cases, product rule. What is the derivative of x times e to the x? So we'll take derivative of x is 1. Derivative of e to the x is e to the x. So we have product derivative of one times the other plus the other times the derivative of the first. So we have the first term will be derivative of x times e to the x plus x times the derivative of e to the x will be x e to the x. All right, what about if we take the derivative of, what was my example, x squared cosine x. Okay, we have two terms. 2x is the derivative of x squared times cosine x, plus derivative of cosine x is minus sine x, so I'll make that a minus sign. So we have minus x squared sine x. All right, for quotients, let's do a quotient here, dx of 2x over x squared minus 1. That is going to be equal to, the derivative of the numerator is 2, the denominator is x squared minus 1, minus the denominator is 2x, and the derivative of the denominator is going to be 2x, divided by denominator squared, x squared minus 1 squared. And then you'd want to multiply those through and do some cleanup there to factor everything and make that nice and tidy, but I'm not going to be concerned with that right now. You can go through that exercise on your own if you like. So chain rule, sine of 2x cubed. Derivative of sine is going to be cosine, so this will be cosine 4x cubed. So we keep the same function inside and we take the derivative of the outside. Then we multiply that times the derivative of the inside. So the derivative of 4x cubed, according to the sum rule and the polynomial rule, is going to be 4 times 3x squared, which is going to be 12x squared. So that result will be 12x squared cosine 4x cubed. All right, and then we have our final example we're going to do is one that will be very helpful to us in a lot of PChem, derivative of e to the minus kx squared, which will be the derivative of e to the x is e to the x, so we have e to the k minus kx squared there. That comes back. Then the derivative of minus kx squared is going to be minus 2kx. So let me get enough room to put that in there, minus 2kx. So the derivative of e to the minus kx squared is minus 2kx, e to the minus kx squared. So those are our 5 rules. So combining the rules for polynomials, exponentials, logarithms, trigonometric functions, and constants, combining those with the rules for multiples, sums, products, quotients, and chains, we can do pretty much the derivative of any value under the sun. Sometimes we have to do multiple of these rules, sometimes we have to do them multiple times, but applying these rules enough times in the proper way can get us the derivative of any function under the sun.